welcome to my talk. My name is Simon Krenger. I'm a technical account manager at Red Hat. And today I would like to talk about Kubernetes, but also about VMs. Because as we all know, containers, they're not VMs, but sometimes they are. So my talk today is about KubeVirt. So we'll see what KubeVirt is, what it is made up, how it's built. I'd like to give you some insight on things that work well and things that don't work well. And there might be some good, some bad, and some ugly reasons why you might want to use KubeVirt. And we'll see what you will need to pay attention to. Good. So let's get started. So I promise this is the only analyst and chart in this whole presentation. As we can see, in the last 10 years, there has been more and more cloud-native workloads that is running in containers. So a lot of workload has moved to containers, and for us as cloud-native people, we like that. That's great. And I would even guess that for many of the companies that you guys work for, the percentage of containerized applications is even higher. Still, this is an industry assessment, so we'll take it as is. What we can see here that there is still a very large amount of applications that are still running in traditional VMs. It is not unheard of that large companies have a huge virtual machine real estate still with tens of thousands of VMs still running to this day. So for us as cloud native people, what does that mean? There is still a lot of work to be done. So VMs, they typically run in traditional hypervisors. And in reality, we see that most of them are operated via ClickOps. So that's just the reality of things. So why would you want to do this thing called KubeVirt then? Right. So maybe you want to ask yourself, okay, you have an application, it runs in containers, but there is this old part that is still running in a VM somewhere. And maybe you would like to manage this thing also with the Kubernetes API. That is really nice. Or maybe your CIO, your CFO, or some manager comes along and says, yeah, that Kubernetes thing you're running, right? It runs VMs too. And you're like, no, it doesn't. But the CIO just received a huge bill from his current hypervisor vendor. And this is where KubeVirt comes in. So you might ask yourself, Simon, but containers are not VMs. How does that work? And you're right. So containers are not VMs. They work quite differently. The fact is that containers, they isolate processes, right? And if on my Linux machine, I run KVM and I run a VM there with my Fedora machine here, I can see that there is a QEMU process that is running. So it's a virtual machine. It's just another process. So this brings us from one thing to another. Why not take this process that we have here and put it in a container and run that container in Kubernetes? So this is exactly what KubeVirt does, right? So KubeVirt is the Kubernetes API for virtualization. You can see there is a Kubernetes cluster. You put KubeVirt as a controller, as an API on it, and then it uses KVM to run your virtual machines. So instead of running containers via C groups and kernel namespaces, we run VMs isolated via KVM, but we will manage them via the Kubernetes API. So KubeVirt, you will typically install via an operator. There are these controllers. And then we will manage VMs by using Kubernetes custom resources in Kubernetes. And we will run the VMs just like that. So let's have a look at how that works in a technical sense. As mentioned before, we take our QEMU process that runs our virtual machine, and we just pack it into a pod and run this pod alongside our existing containers. So there's nothing special about this pod that will then run this QEMU process. Well, granted, it will be rather large, right? As we know, virtual machines can become rather large from a CPU and memory perspective. But, from how you manage it, the pod itself is still the same thing. Well, and then there is the problem of state. So most VMs have a lot of state, right? So we will keep the disk of that virtual machine either as a file or as a native persistent volume. and we'll just use PVs in Kubernetes to store the disk image or use it as block. This means that we can have our state, so the disk of the virtual machine, and store it on a persistent volume. Now, when we put this disk on a storage that allows read-write many, this means that we can even do things like live migration, what you would expect from running VMs. So you can move your VM running on one hypervisor node to another. So from one Kubernetes node to another. We'll see that disk file. We'll have a look at it in the demo later on. So let's dive a little bit deeper and quickly look at what KubeVirt actually does and how it actually works. So here we find this is from the KubeVirt documentation. And so let's have a closer look. So here on the left, we can see there are the control plane components, right? So KubeVirt is typically installed via an operator, and this operator then deploys all the other components. This is not on the slide, but we'll see it later in the demo. We'll see that operator running. So on the one hand, we can see the KubeVirt controller, and it does what it says on the tin. It watches these virtual machines, these objects, these custom resources in your Kubernetes API, and manages the pods based on what you specify in the Kubernetes API. Then there is also an additional API that exists that KubeVirt implements to manage your VMs, right? You can think of things like, okay, I need to access my VM somehow via a console. Oh, okay, so this is the API pod that provides these kinds of functionalities and is aggregated into the API server of Kubernetes itself. Good. So this is the control plane, right? So there are some central components that manage our VMs. And then on each node, there is also a daemon set that runs, and there is this virt handler pod. And this virt handler pod then needs to manage everything that is outside of the VM. So we're talking about storage things, networking things, plumbing these things together. So everything that is outside the VM and not part of the VM, this is then what is handled by these virt handler pods. Deployed as a daemon set, it runs on all the nodes where you want to run VMs. This is what it does. Then now comes the interesting part, the VM itself. All right. So for each VM, we'll see also in the demo later on, there is a separate pod. So remember, we've talked about this, that every VM has its own pod, and you can see it in Kubernetes and manage it like any other pod that you would have. The pod itself is called virt launcher, and this is the pod that then runs the QEMU process. But this pod also has a local libvirt instance, since it runs in a container, it provides the C groups and namespaces for the KVM process, just like a normal pod. One important thing, and this is where we can see now where, let's say, cloud native concepts and the VM world collide. The one thing that pods also needs to handle is Linux signals, right? So what should happen if Kubernetes tells this pod that it should stop? Now, it will depend on the configuration, of course. So will it be live migrated to another machine? Should it be actually stopped? So this is then, we'll discuss it later on as well, where the two worlds clash a bit. But this is also something this pod does. And finally, of course, we have the QEMU process that runs the actual virtual machine using the KVM features of the kernel. But just because it says QEMU, right, people think, oh, this is emulated things. This is not always the case. So if you run QEMU on an x86 machine and you run a x86 virtual machine, there is nothing emulated, right? So the hardware virtualization features of your hardware is being used to do the virtualization, and there is no emulation in place. Of course, because there is QEMU, you could do that. So if you want to run your Spark instances or whatever in your Kubernetes cluster, I don't know why you should, but hey, you can. You can do that. I would not recommend it. Still, the option is there, right? That is really nice. So as we can see, there are a lot of moving parts. So yeah, let's hop over to the demo and see how it actually works. Now, I've never done a presentation on such a big screen, but we can see it, huh? Good. So let's start by having a look at, I have a local kind cluster running on my laptop here. And yeah, let's see what pods we are. So I installed my KubeVirt, of course. Let's make it a bit bigger. Okay, doesn't work. Anyway, let's make it bigger. So what we can see is that on the bottom there, you can see the the operator itself. You can see the controller. This is the control plane component, right? You can also see the Virt handler, the Virt handler pod. This is this daemon set we talked about. And then at the very top, we can see some of the components that are necessary to handle storage. A whole other topic we will talk about later on. Good. Nice. So let's have a look with KubeVirt. Of course, you have a lot of CRDs, right? You see the whole list, very nice. The most important one is, of course, the virtual machine itself, right? There are also other CRDs that you can use for the data volumes, for example, so the storage basically that then uses a PV. But we can see that KubeVirt comes with a lot of custom resources that are then used to run these the VMs. Good. So next up, we'll see. We cannot see it very nice down here, but at the moment there are no pods. And now let's have a look at the YAML file. That's a really big YAML file here. Anyway, but this YAML is a kind of virtual machine, right? And it has the things you would expect a virtual machine to have. We can see the number of CPU cores, the memory, all the kind of things. We can see devices. We could add very interesting devices here as well. We can see the machine type. So this is the common machine type, Q35. We can also run all the machine types. And now here again, we see a bit the interesting part. Because this is a pod, as any other pod, we can define readiness probes. Have you ever seen a virtual machine with readiness probes? Wow, amazing. Now, we'll talk about this readiness probe again, if it's a good idea that if you stop your SSH daemon in your VM, that the pod is restarted. Anyway, moving on. As in every good cooking show, I have prepared the Fedora machine already because to download this thing does not work. And here is a bit of cloud in it, which we can use to then fill out our virtual machine. So, you know, nothing that is really very exciting, but just a virtual machine, as you would expect. Anyway, let's apply this. We cannot see it very well, but it has been created. So if we then actually get the machine, maybe we can turn down the Maschinenwerfer abstellen. Oh, very nice. Down here we can see it. It is stopped at the moment. And then when we can then use the virtctl command, which is like a little wrapper around kubectl that you can use to run, VM-specific things, such as starting a VM or having a look at the console. So we'll use that in a second. So let's start this one. As you would expect, this basically edits the YAML and puts, it should run there, and then we'll do that. So if you get it again, we'll see it's now running. It's a very small machine, so it doesn't do much of things. And if we now have a look at the pods, right, you will notice, there is now a Virt launcher pod that is running with the readiness probe and everything running, and also an IP. And this will come in handy later on. But what I want to say is, hey, we have a VM object here now, and also a nice pod that is running our QEMU process. Right. So together with the virtual machine, the virtual machine is like a pod, as we said before. What we also get for free is the virtual machine instance. So you can think of the VM a bit like a replica set, and then the virtual machine instance like the pod that is actually running. So we get this virtual machine instance that will also run. And this thing will handle things like, live migration for us when there are two instances running at the same time for a very short period. So this is what this thing does. Good. So we can then, of course, do the console, right? And then, we get this nice console. Let me do this so I can move it up a bit. I have a very secure password, 1, 2, 3. There we go. Good. So now we're inside the VM, of course, and as we would expect, right? It has been just started 1 minute ago, and we were now inside this machine. We have, let's see what I have here on my machine. Proc CPU info. Let's see. Oh, very nice. Xeon processor in my laptop. Very nice. Okay, good. So this is, of course, in the VM, and as we would expect, also it has an interface, a network interface with an IP. And if you have paid attention, you will notice that this IP is the IP in the pod network. And this will bring us to an issue later on, right? So this will stay important. So remember that one. Good. Now go out of here. Very nice. Anyway, so we can see that this is running here. And now, of course, this is the pod that is running, right? Let me export this and then have a look at inside the pod. I can then use the kvm commands. I know the virsh command, right? I can list the VMs that are running inside this pod. And inside the pod, I can also run, for example, the interface list, can get it from the kvm virtualization, and then I can see, this is the MAC address, very nice. And lastly, what I already alluded to is there is a disk image file that is on a PV somewhere, and this is basically where the state of this VM lives. So inside the pod, a QML process is running. We can interact with it with like any other KVM virtual machine. Inside that pod, the disk that is being used is either a block PV, or in this case, it is a PV with file system, and this has then an image in there, right? Very good. So that was the demo. Let's move back to the slides then. Very nice. All right. So this is the green slide. You will notice there are a lot of green things on here. So that was the demo, and we saw how nice it is to interact with VMs with the Kubernetes API. So if you interacted with other hypervisors before, they all have their different things, how it works. But what we saw now is we can use the Kubernetes API to interact with our virtual machines. And what does it mean? We can use all our nice cloud native tooling that we all like and know to manage these VMs. So imagine you can now manage your VMs using GitOps. And so if you've dealt with other hypervisors before, this might blow your mind. So compared to managing these with ClickOps, you can have a proper API, you have the Kubernetes API, and you can use GitOps. How nice is that? So with Kubernetes come a lot of other nice cloud native things that come out of the box with Kubernetes, right? So think of the possibilities you have with auto-scaling your hypervisor host, right? Like you can do with Kubernetes. Think of all the automatic reconciliation that happens when something goes wrong, right? When there is a disruption, think of all the self-healing things, the readiness probes. Again, to come back to this readiness probes, this is a bit of a double-edged sword. Sometimes it might be a good idea, but sometimes it's also not a good idea if you stop your service inside your VM and then the whole VM is restarted. Doesn't really work well, but it's there. So if you have really nice VMs, then this might be a possibility. So lastly, the KVM and QEMU are really mature projects. They've been around for forever, and this works quite well. So the virtualization itself works quite well. Now, I've said this is the green slide, and you know what's next, right? So now here is the orange slide. Now to the challenges. The biggest challenge that comes, when managing VMs on Kubernetes is mindset. VMs are not made or are only partially compatible with the cloud native concepts. There's a large gap of mindset between how teams operate them. And some of us who have spent the last 10 years doing cloud native stuff, some of the things that are done in a virtualization world seem very foreign to us. So here I don't really have a solution for it, but a large portion of empathy when working with virtualization teams, bringing them onto a cloud native world to see what we can do. Good. Apart from the cultural things and mindset differences, there are also technical issues or challenges, as you once said, that we need to talk about today. So there is a significant difference on how traditional hypervisors and also how Kubernetes consumes storage. So with hypervisors, you might have large storage volumes somewhere. And with Kubernetes, you have a lot of small ones. And depending on the storage and your CSI driver, this works well or it doesn't work very well. So in practice, we have seen significant issues with how PVs, how storage handle a massive amount of PVs. So there's a huge gap sometimes between what the storage vendors tell you and what they can actually do. Then this I also already alluded to is that VMs have very much different requirements when it comes to networking. So containers, as we all know, they run in the container network, the pod network. You get an IP from there, and you don't really care about this IP. It changes anyway. So, and you're inside your Kubernetes cluster, right? And it's not exposed to the outside world typically, unless you configure that, of course. But having an internal IP for your VM is not exactly what you want typically, right? So here, again, it will depend heavily on your CNI that you're using, that what capabilities you have and what you can do, how you can expose your VMs within Kubernetes to the outside world. Most of the time, you will need to manage some kind of VLANs. You will need to maybe even manage BGP, things like that. There are a lot of CNIs that can do it, but there are also a lot of CNIs that cannot do it. Lastly, and this goes into the same discussion as before that we had with the readiness probes and the mindset, there are significant differences on how you would operate VMs versus how you operate containers. Another good example is, let's say a Windows admin goes into his VM and shuts down the Windows VM. What do you expect to happen? So for cloud native world, we have it defined in the YAML, the machine should always be running. And when the Windows admin shuts down his VM, it will just auto restart, right? And this is maybe not what you want, right? So here, there is a bit of a clash between how sometimes you manage VMs and how you manage containers. So this is a challenge as well. Good. So this is things that we should have a look at. Now, before we wrap up, let's talk about the use cases. So generally, there are two strategies what we can use KubeVirt for. One is modernization, and the other is replacement of existing hypervisors. So let's talk about modernization. As I said at the very beginning, you maybe have your application, and there is still these VMs running somewhere else, and you would like to modernize it, right? And at the moment, you don't have any time to really, get it out of the VM and into a container. So this is a possibility that you run your VMs the same way you run your containers within Kubernetes with the same API, with GitOps and everything, but you just run it in Kubernetes. And then at a later point in time, which may or may not come, you will then migrate it or actually modernize your application, put it in a proper container. So this is the one use case. The other use case is that you would say, okay, I want to reduce my, my existing hypervisor footprint, for example, and I would like to have a more modern solution where I can use APIs to control my VMs. And here you would replace your existing hypervisors. So you would have a separate cluster typically where you would just run VMs and no containers, or just a little bit of containers. So both of these are valid use cases, right? This works well with Java applications, your IIS things on Windows, application servers and such things. So this works well in general. There is no problem with that. Now, where it does not work well is when you want to run VMs with super special requirements. For example, if you have applications that require a real-time kernel, for example, this is not a good use case for KubeVirt. Or what we see more also in the field is that there is very old operating systems, and you would be surprised on how many Windows NT machines there are still. So running open servers, the old Solaris things, Windows XP, things like that in KubeVirt might be a challenge because it has a very modern hardware profile. Let's put it this way. Then last but not least, there are applications such as SAP and Oracle, where the vendor itself has not certified KubeVirt for running the application itself. So here you would need to talk to them to see, hey, is this a possibility that you would support me even if I'm running on KubeVirt? Right, so we've heard about some good, bad, and ugly use cases now. So let's wrap it up. So to repeat a few key points, so KubeVirt is a great solution if you want to run your VMs the same way you want to run your containers. It's both a solution for things you want to modernize and things you want to replace. A good implementation very much depends on your CNI and your CSI driver. So there are large differences in that. And yeah, last but not least, managing VMs via GitOps is really, really cool. And that's it. Thank you very much.
Thank you so much, Simon. Are there questions?
Hi. Hello. Okay. How would the migration from well-known virtualization provider looks like in the real environment?
Right. That's a very good question. So of course there's tooling. The tooling exists. Yeah, so what you saw, and in my demo as well, there was a pod running. This is this CDI, it's called. It's a part of the KubeVirt project where there is tooling available for doing just that. So from existing providers to export your disks and everything into Kubernetes, and then to basically start the VM with the same configuration. So the tooling exists. It's also provided partially by the KubeVirt project. So yeah, it exists, and we can have a closer look at it if you want. You can meet me later on.
Thank you. Other questions?
Up there.
Oh, that's a long one.
Yeah.
Thanks for the talk. You mentioned migration. I also have a question regarding migration, but not the same type. Is it possible to live migrate a VM from a node to another node?
Yes, that's possible. So how technically it would work is, I have a slide for this here. So this one. So how it would work is you would need to make sure that the storage that you're using, so the persistent volume in Kubernetes that you're using, is using read-write many. And then QEMU basically comes with the capabilities to do that. And so KubeVirt has the capabilities to live migrate from one node to another. So yes, it exists. It just needs a PV, which is read-write many. And that's it. And then you can live migrate from one host to another, and there will be no interruption to the VM itself.
Thank you. More questions?
Over there.
So you said before it's not emulation, it's virtualization, but is there still a performance impact since we have so many layers of virtualization with that approach?
Right. So yes, but it's a very small one. So if you're running x86 virtual machine on an x86 host, the overhead is very, very small. So lower 1-digit %. What QEMU does emulate is things like networking cards, disk drives, things like that. This is emulated by QEMU for your virtual machine, but just for CPU performance, there is a very, very low overhead. Just like you would expect with your existing virtualization solution, there is an overhead, but a very small one in my opinion. Yeah, and of course it will always depend on your actual workload, how sensitive you are. And it's something you would need to test.
Thank you.
Thank you.
Other questions? Oh, good. So I would say thank you again, Simon. And the next talk is at 4 here. It's from Marco Kundig. Thanks so much.